Video, we are going to have a look at correlation and regression analysis. Okay, two of the many different techniques for forecasting or predicting what might happen in the future include regression analysis and time series analysis. Okay, so we're going to have a look at regression analysis today and time series analysis in another video. Okay, so before you can make a prediction about what could happen in the future on looking at various quantities of data, you need to first find out the strength of the relationship or the correlation between the two quantities. Okay, so if we can identify how one quantity is influenced by another, then we can make useful forecasts about the future. Okay, so perhaps call centre wants to look at the connection between the number of calls and the number of sales. Production company, if more time is spent on training, okay, does this reduce waste? So it's always possible to find a relationship, but you need to think sensibly as to whether or not there is a strong connection between the two, okay? So we need to find out the strength of the relationship by calculating what we call the R number, which is the correlation coefficient. Okay, R can only have two values between -1 and +1. Okay, when R is -1 or +1, then we have what we call a perfect correlation or a very strong relationship, okay, between the two quantities. If R equals 0, then we have a 0 correlation, okay, so therefore no relationship at all. Okay, so we don't have to worry about how to calculate all of these things. Excel does it for us. We just need to interpret the results. Okay, so when R or the correlation coefficient equals -1 or +1, then we say we have a strong relationship between the two quantities. And when R equals 0, okay, there is no relationship at all between the various quantities. Okay, so when you first try to relate quantities, you must first of all draw a scatter diagram to give clues about the relationship between the two figures, okay, or the quantities. So we're going to have a look just now at a file that I already have. I'll share this with you just now. Okay, so you can see here we have a chart, okay, a scatter diagram that is asking us, is there a relationship between the amount spent on advertising, okay, on our x-axis, and the resulting sales on our y-axis? Okay, so you can see here the values here for advertising costs and sales. Okay, so we have a trend line in here, okay, which is a linear trend line because it's almost a straight line. And we've got the equation of a straight line here, and we also have another value, the R squared, okay, which is called the coefficient of determination. Okay, basically, how much the change in Y, okay, or our sales, okay, is as a direct result of changes in X, which is our advertising costs. Okay, so how on earth did we get there in the first place? Okay, so let me just, get rid of that. Okay, so we would select the data, okay, A3 to B12, and I'm just going to say insert, okay, the chart is a scatter or a bubble chart. Okay, I'm just going to take the very first one. Okay, and you can see I'm just going to pop that there beside my one. Okay, I'm going to insert a trend line. Okay, so right click, add trend line, and it will default to linear. Okay, what also I want to do is scroll down, and I want to display the equation, okay, of the straight line on the chart, and I also want to display the R squared value on the chart. Okay, so remember the R squared is the correlation coefficient, okay, so telling me how much the changes in sales comes as a direct result of increased or changes in our advertising costs. Okay, so I'm going to click on them and pop that there. Okay, so you can move that about. Obviously, you can add your X and Y axes, which I've already done in the previous version. Okay, so remember, just add your axis titles in as we've done in the past and change your title to something meaningful. Okay, I just wanted to show you how I got this chart in the first place. Okay, so we also need to add in, okay, the equation for correlation. Okay, so our reliability, is there a relationship between the two values? Okay, so you can just start typing in equals correl, okay, open brackets and go up into the FX. Okay, or you could have just typed in, clicked on the FX and searched for correl. Okay, so as I say, Excel does the calculation for us. Okay, so we are going to find out, okay, how strong the relationship is. Okay, so between the two sets of values. Okay, so array 1 will be our advertising costs. Okay, and array 2, our sales figures. Okay, and okay that. You can round that up. Okay, so we can see here that there is a very strong linear relationship between costs and sales. Okay, because we are sitting here at a value that is very close to +1. Okay, so if I get rid of my decimals, okay, we're sitting here at 0.97. Okay, so we can also see, okay, that the R squared, okay, the correlation, the coefficient of determination is sitting at 0.95. Okay, so the correlation or the relationship then is sitting about 0.9, 0.97, okay, and the R squared, the coefficient of determination, okay, is sitting at 95%. So we can therefore assume that 95% of the variation in sales, okay, is a direct result of the advertising costs, okay, and 5% is due to something else. Okay, so basically increase in advertising costs has a direct result in increased sales. Okay, so for the purposes of this exercise, okay, and units, we are only looking at linear relationships. Okay, there are also other options for non-linear. Okay, but for the purposes of this exercise in this unit, that's all we're going to look at. Okay, so again, what we've said, the R squared, okay, is the coefficient of determination. And we have the coral here, which is our R, okay, which is the relationship between X and Y, advertising costs and our income from sales. Okay, so just to reiterate, an R number of 0.9, okay, it's very close to 1. So we have a strong relationship between advertising costs and income from sales figures. Okay, and our R squared is 95%. Okay, so we can assume 95% of variation in sales is as a direct result of the advertising costs, and 5% is due to something else. Okay, thank you for watching.